ID 74103. For integers n greater than equal to 0. Which kind of integer they are taking? N should be greater than equal to 0. Let Fn from close interval 0, 1 to R. Let Fn from close interval 0, 1 to R be defined by, how it is defined? It defined as Fnx is equal to x by 1 minus x to the power n. This is the function whose domain is 0, 1, minus 1, 0, and its range, its domain is minus 1, 0 in closed interval, and its codomain is R. Be defined by, that function is defined Fnx as x by 1 minus x to the power n. Which of the following statement is true? They are asking which of the following statement is true about the series. They are asking about the series. This statement is true. What is the series? Sum of Fn, n varies from 0 to infinity. What are those answers? So they have given 4 options. What are those options? First option, the series is neither absolutely convergent nor uniformly convergent. First option is saying that the series is neither absolutely convergent nor uniformly convergent. Second option is saying that the series is both. It is uniformly convergent as well as and absolutely convergent. The series is both absolutely convergent and uniformly convergent. The series is absolutely convergent but not uniformly convergent. Option 3 is saying that the series is absolutely convergent but not uniformly convergent. Option 4, the series is uniformly convergent but not absolutely convergent. Option 4 is saying that the series is uniformly convergent but not absolutely convergent. The series is uniformly convergent but not absolutely convergent. Going ahead, solution. So first, what we have to we have to check out, is it absolutely convergent and uniformly convergent. So first we will check absolutely convergent. Absolute convergence. Check. We examine the series of absolute value. We will examine the series for absolute value or for of absolute value. So sum of mod of Fnx. To find the absolute value, we have to take mod. So mod of Fnx is equal to sum of mod of functional value at x is x by 1 minus x to the power n, and is equal to that modulus you are taking, because those things which varies is n from 0 to infinity. So n from 0 to infinity, so only those terms who are dependent on n, they can they are variable or they are useful here for summation purpose, and all other term we will take out. So it is mod x sum of 1 by 1 minus x to the power n. This is a geometric series. What is this? This is a geometric series with ratio. What is the common ratio? 1 by 1 minus r x. This is the ratio 1 by 1 minus x. Since x, we know x means domain is close interval minus 1 to 0. So 1 minus x, what will happen? 1 to 2, how it will be? Just 1 minus x. Put value of x from here. This value of x you put here. So when you will take minus 1, it will become 2. And when you will take 0, it will become 1. So obviously it will become 1 to 2. So r, what r will become? Just put 1 minus x value here, you will find the r. So put 1. So 1 by 1, 1 minus x, in 1 minus x plus 1. So 1 by 1 is 1. And when you will put 2 in place of 1 minus x, it will come to 1 by 2. 1 by 2 is, so r value is 1 by 2. So r value varies from 1 by 2 to 1. Any value between this, it will take taken by r. The geometric series converges if r less than 1. What about geometric series? The geometric series converges. This geometric series, whatever is there, this geometric series, this this is not, this is the ratio of the geometric series, and this is the geometric series, or you can say this whole is geometric series, and this is the common ratio. So geometric series converges if r is less than 1. If r is less than 1, then this geometric series will converge. which occurs when x not equal to 0. And when it will converge? When x is not equal to 0. If x is not equal to 0, if x is not equal to 0 and this r value is less than 1, r value is less than 1, then we will say it is convergent. However, at x equal to 0, what about at x equal to 0 when x will be 0? When x will be 0, the series trivially converges. When x will be 0, then what we will say that series trivially converges to 0. It will converge to 0. Thus, the series converges absolutely for all x between -1 to 0. That's why it will converge for all x between in closed interval -1 to 0. How it is 0? However, at x equal to 0, how this is trivially converges to 0? Because this one is depending on mod x. When mod x is 0, then these all are going to 0 at x equal to 0. So that's why it is the series converges absolutely for all x belongs to closed interval -1, 0. Uniform convergence. Uniform convergence. Now we have to check uniform convergence. To check for uniform convergence, we consider the behavior of the partial sum. How we will try to know about the uniform convergence of that series. So to know that, to check that uniform convergence, we consider the behavior of the partial sum. So what we will do? We will check the behavior of the partial sum. So sum of f and x is equal to what will come x by 1 minus x to the power n. So it will change x outside. Sum of 1 by 1 minus x to the power n is equal to x, and this will change how? 1 by 1 minus x to the whole to the power n is equal to 1 by 1 minus this whole 1 by 1 minus 1 by x. Okay, and here when we will solve this, then it will become x into this will come here. So 1 minus x minus 1, it will come minus x, and whatever downside is there, it will go upside. So it will become 1 minus x by minus x, and x will cancel. So here it will come minus of 1 minus x, it will come x minus x, x minus 1. Okay, for x is from closed interval -1 to 0. At x equal to 0, the sum is 0. At x equal to 0, the sum is 0. At x equal to 0, whenever x is 0, then this whole sum will become 0. The pointwise limit function is, whenever we are talking about pointwise limit function, what will happen? Fx will be 0. When x is 0, then fx will be 0. When at n tends to infinity, limit n tends to infinity, f and x is same as this, and it will become 0 if x is 0. It will become x minus 1, this one, here x minus 1, when if x is from closed interval -1 to 0, this one. Okay, so the function is not continuous. Function is not continuous. In open interval, it is like in open interval. If I talk about open interval, here in open interval, it is getting at x minus 1, but at 0, at this point it is going 0. So what happens? It is not continuous at x equal to 0. Since what is the reason it is not continuous? If you take limit fx tends to 0 minus, if you take right side of left side of 0, because right side it is out of the interval, so you have to take left side 0 minus 0 minus. So whenever you will reach, you will get x minus 1, and x value is 0, so 0 minus 1, it is minus 1. So all the values who are left of the 0, in that value they are giving -1, but at 0 it is giving to 0. So it has two different value, -1 and 0 at closed interval is -1 to closed interval -1 comma 0. So that's why this is not continuous. However, partial derivative, partial sum. If I talk about partial sum, however, partial sum means s and x. So s and x, this is the partial sum. How we are defining? N is here, so we will sum that functional value from n barabar 0 to n is equal to 0 to n, and x is, since it is not depending on n, so it will go outside 1 by 1 minus x to the power whole n. So it's continuous on closed interval minus 1 comma 0. However, each partial sum is continuous. Partial sum is continuous on closed interval 0 comma 1. If the series were uniformly convergent, the limit function f(x) would also be continuous. Partial sum is continuous, but the series, if I talk about series, they are uniformly convergent. They were uniformly convergent. If the limit function also be continuous, limit function is also continuous, then, but limit function is not continuous. Since f(x) is not continuous, the convergence cannot be uniform. The convergence cannot be uniform. Since f(x) is not continuous, we have already seen that function is not continuous. The convergence cannot be uniform. That's why that this is not uniform convergence. So conclusion is that the series is absolutely convergent for all the interval, for all x who are from closed interval minus 1 to 0, but it is not uniformly convergent. But if I talk about uniformly convergent, it is not uniformly convergent due to the discontinuity in the limit function at x equal to 0. Why it is not uniformly convergent? Because it is discontinuous at x equal to 0, and that's why it is not uniformly convergent at that place. Okay, so final answer is that option 3 is the final answer. The series is absolutely convergent but not uniformly convergent. So this is the final answer. That's it.